Hey guys, and welcome back to another installment in this series. Now in this video we're going to be taking a look at control structures and a couple of other functions. We are still building the Hangman game, so at the end of this video we will update our Hangman file with the new concepts. But first, let's take a look at control structures. Control structures generally include comparison operators, conditional statements, and loops. We're going to take a look at comparison operators first. Now up here I've listed a couple of them, the first being the equivalence operator identified by the double equal sign. Then we have less than or greater than, we have less than or equal to, we have greater than or equal to, and we have the not equal to. Now in an earlier video I mentioned the Boolean type and that it returns a true or false value. Now, often when we work with control structures, we get back a truth or false value and execute an operation based on what we get back. Now, I've written down a couple of examples here to illustrate this and demonstrate the operators as well. So basically in these lines I'm going to be checking for equivalence between 5 and 5. I'm going to be checking if 20 is less than 3, if 10 is less than or equal to 13, and if 6 is not equal to 6. So if I just save this and run it, we get back our results, and we see that when we check for equivalence between 5 and 5 we get true. When we check if 20 is less than 3, we get false. When we check if 10 is less than or equal to 13, we get true. And when we check if the integer 6 is not equal to the string 6, we get true, because 6 int is not the same as the string 6. Okay. Now there are also a couple other comparison operators that are not symbols, however they are keywords. I've just pasted them there, and these can actually be joined together. A couple of these can be joined together to create a different evaluation. So I will make a simple example. For instance, what the AND operator does is return a truth value if the two things being compared evaluate to true, otherwise it returns false. So for instance, if we were to take this here, if we were to take 5 is equivalent to 5 and 10 is less than or equal to 13, we put AND there, and then we paste this. We just mute, we just comment these out. So if you save that, if we save this, we actually need to do something else as well. So if we run this file, what we're basically doing is checking if 5 is equivalent to 5, which comes back as true, and if 10 is less than or equal to 13, which also comes back as true. And if both of these are true, then the output is true. So if I change this and say 10 is greater than or equal to 13, and I change that there as well. Okay, I didn't change this. Now we get back false because 5, yes, is equivalent to 5, however 10 is not greater than or equal to 13. So that's why we get true and false here. And if both of these are not true, or if both of these are not false, then our output is false. Now a different operator we can use is the OR. So we can use OR instead of AND, and what OR does is Rather than checking if both values are true, it only needs one of them to be true in order for it to return a true value. So if we run this, we get back 5 is equivalent to 5, which is true, and 10 is greater than or equal to 13, which is false. However, because we have one truth value, the comparison returns a truth value as well, or the comparison evaluation returns true. If we swap these around, for example, or rather let's say that 10 is less than or equal to 13, and then say that 5 is greater than 5. Need to change the string as well. Now if we compare these, we find that 5 is not greater than 5, which is why this is false, and 10 is less than or equal to 13. Or rather it is less than 13, that is why we get true. And so because one of these are true, the evaluation results in true. Now another comparison operator in the list is the in operator, this one here. How we can use that is, for instance, we can declare a variable and give it a name. Let's say Hangman again. So a variable is Hangman. Now what we can do is check if a letter is in the word. So what we can do is open a string and write in the G, for instance, and say G in word. And what this does is it checks if this string is in the other string, and then returns true or false depending on whether or not the string is found. And there we have it. Okay, so we can also print our word. And there we have it. G is in Hangman, which results in true. Now, like I mentioned, we can also combine a couple of these, so we can also add the not operator. We can say that whatever letter we're looking for is not in the word. So for instance, if we say R is not in the word, then we'll get back a truth value because the letter R isn't in the word. However, if we do have a letter that is in the word, like if we use G again, and we say that G is not in the word, we get back false because G is in the word. Similarly, we could also have mixed and or together in an operation. We could do something like 5 is greater than 5, or 10 is less than or equal to 13. So here we would generally use brackets so that we can preserve the order of operations. So we'd say 5 is greater than 5, or 10 is less than or equal to 13, and 6, the integer 6 is not equal to the string 6. If we save that and we run it, we get false, true, and it's true because the main evaluation is the OR, and the OR statement is checking if 5 is greater than 5, which is false, and then it's checking if 10 is less than 13 and 6 is not equal to string 6. This evaluation equates to true, so because one of these evaluates to true, we get a true evaluation. Now the final one, which is the is operator, can also be used similarly. However, you need to be careful on how you use this one. For instance, you could say 5 is 5, which would be similar to saying 5 is equivalent to 5. However, it is not necessarily the same thing. The correct use of is would be to check if a variable is the same. So we could do something like this. We say let's make 10 here instead, and we could then instead print variable is variable, and we save that. And you'll notice we get a syntax warning. This is in response to this first instance where we use the is. So like I said, using is for these values is not exactly like checking for equivalence, whereas when we assigned the value to a variable and we used the is comparison operator, we didn't get any warnings. So if I comment this out and I run the program again, you will notice that we don't get any errors. So yeah, we don't really use is when we're using true values. We usually use is to check variables. Now we're going to take a look at our Hangman project again, but before we get into that, what I'm going to do is I'm going to introduce a couple of new functions. So similar to how the print statement outputs something into the terminal, we have a function that takes in input from the terminal that we can use in our program, and that is the input function. So for instance, we can declare our word again, can declare word and say word is Hangman. And now similar to before, when we checked if a letter was in the word, we can do the same thing. However, we can dynamically get input, so we can say guess is equal to input, and then similar to the print function, the input function also takes a string, or can also take a string. However, the string that we type in here is going to be what the prompt is in our terminal. So I'm just gonna print it out real quick and then show you. So if you run this, the text that we put in between the brackets here is what our prompt is, and then we can type in our guess, and we can guess G, for example, and then G is printed out. Now we can use this and use another comparison operator and say guess is in word. And when we make our guess, let's type in G again, we get true. Now, the thing about strings is that they are also case sensitive. So for instance, if I run the same program again and I guessed G, however the G is a lowercase instead of an uppercase G, it will return false because the strings are case sensitive. So a way to get around this, you see, true again. So a way to get around this would be to include a method to your input statement that would change your input after you have entered it. So we have two methods of doing this. We can either use the upper method, which will turn whatever we enter in the string to uppercase, or we can use lower, which will make sure that everything that we enter is turned back to a lowercase. So I'm going to use upper instead. And if we save that, and we need a way to actually see that there has been a change in our string. So we're going to print out the guess, and there we have it. We entered a lowercase g and we printed out our guess, and it was a capital letter G, and then it evaluated to true because a capital letter G is found in our Hangman. Now if I run the program again, and let's say I guess man, let's say my first two letters are lowercase and the last one is a capital letter. You see it changes the entire word to capital letters, and it evaluates to true because man is found in our word. So now we have a way that we can dynamically take in input and make sure that it is all the proper case. Now the next thing we're going to do is we're going to look at conditional statements. Conditional statements is another part of control structures. What conditional statements allow us to do is to check if a certain condition is true, and if a certain condition is true, then we can do something about it. So for instance, I clear this out, I'll just remove this space here, and I could do something like this. I could say if guess is in word, then print, we can print an if string and say guess was found in word. If we save that and we run it, it says make a guess. We guessed letter M, and it says M was found in word. And we can run it again. We can guess a couple of phrases. We can guess hang, and we run it and it says hang was found in Hangman. Now what if whatever it is that we guessed wasn't in the word? Then we would need a condition to handle that event. So we could easily just type in else print incorrect guess, and we run that. Now if for instance we guessed a letter that wasn't in the word, like O, now we can have incorrect guess print out. Whereas if we find something in the word like man, it will print man was found in the word. Now what if we wanted to check a separate condition? Let's say we wanted to check if the entire phrase that we guess is the word. So we could do something like elif. Now in In other languages, you can do what is called the else if statement, where you just write an else if like that. In Python, that has been simplified to just elif. So we can say elif guess, oops, if guess is equivalent to word, then we can print out you guessed the whole word right. We save that. Now actually we need to swap these around. If I wanted to be more tactful about it and just do something like this instead, and then take this, put that there. Now I can check first if the guess is identical to the word before checking if a phrase is in the word. And if we just run the program, now we can check for a letter. Now O is not in the word. Now if we run the program again, we can check for A, and it says A was found in Hangman. If I check for the entire word, if I typed out the entire word, now it says you guessed the whole word right. So what this did was it first checks if the entire guess is correct. If it's correct, then it'll print this and then it'll exit the program. If the entire word, if my guess wasn't entirely correct, then it will just check if the phrase that I entered is in the word, and then it will print that out. And if that's not true, then it will just print out that I made an incorrect guess. You can add as many else if statements as you want, and you can also add you can also nest if statements underneath your else if statements and your else statements and your if statements. So you can nest as much as you want. Now the final concept we're going to be looking at related to control structures is loops. Now when we ran this program before, we had to restart every time we finished. So we had to make a guess and then we print it out, and if it was wrong or if it was right, we'd still have to rerun the program each time. Now what loops allow us to do is to run the program as many times as we want until we decide that we want to quit the program. So with loops, there are actually two kinds of loops. You get the while loop and you get the for loop. Now I'm going to show I'm going to show the while loop first, and then I'm going to explain what the difference between the two are. Now basically the for loop is used if you know exactly how many times you want to run a particular program, or if you know how many times you want to go over the section in your program. And the while loop is used if you don't know how many times you'll be going through the program. So to demonstrate this, I can create a variable called play on, and then assign the value true to it. Okay, and I can say while play on, which would be equivalent to saying while true. So while this condition remains true, then do something. What are we going to do? We're going to get input. So let's come here. We're going to get input, and then we're going to print it out. Okay, I'm just gonna comment these line of code out. Now if I run this program, it says make a guess, and we make a guess P. It says make a guess again. You see, now we don't have to leave the program, we can just keep guessing over and over and over. However, you notice that we can't leave the program anymore. That's because we used a while loop, and a while loop needs a stopping condition. So if the while loop doesn't have a stopping condition, it'll keep running forever and ever, which is what is referred to as a infinite loop. Now, if you ever find yourself stuck in a infinite loop, or if you just want to exit a program in Python, what you need to do is just type in Control C or Command C. So how we go about fixing this problem is by creating a stopping condition for the while loop. Now the stopping condition here we can create is to change our play on value to false. So we can do that by evaluating a certain condition and then changing the play on if a certain condition is met. So for instance, we can say if our guess is equivalent to the string exit, then turn play on, change the value of play on to false. And what this will do is, what's going to happen is the program is going to start, and it's going to evaluate to true, play on is going to evaluate to true, and it's going to ask you to make a guess, and it's going to check if your guess is exit. If it isn't, then it'll go back to the top. It'll get to the top and it'll evaluate that play on is still true, and then it'll go on and on and on until your guess is exit. Now if your guess is exit, it'll turn play on to false, and then it'll go back to the top, and then it'll try and go into the program again, but it'll realize that play on has been turned into false, so it won't go through with the program anymore. So just to demonstrate that quickly, say make a guess, we make P, we guess P, we guess L, we guess U, we guess W. Now we guess the word exit, and it prints out exit. Oh, I see. Because we changed the case of the word, we also have to change the case here. So this has to be an uppercase exit, not a lowercase exit. So that's actually, I'm glad that happened. Something to be careful about. So we guess P again. We guess F, we guess H, and now we guess exit, and now it prints exit and then it leaves the program. So that's basically how a while loop would work. And if we wanted to use a while loop with our program, then we could do something like this. Now we could say, take this and paste it here. Now we can say, okay, we need to take our word, okay, so now we declare our word and then we initiate our while loop. We give play on the value true, and then the statement essentially is saying while true we make a guess, and then we print our guess, and then it says if the guess is in the word, then if the guess is equivalent to the word, print you guessed the whole word right. If the guess is only in the word, then print the guess was found in the word. Otherwise, print incorrect. And then we check if guess is equivalent to exit, play on is equals false, and then we exit the loop. But instead of putting this here in the bottom, what we can do is include it in here as an elif statement. That way it doesn't print incorrect guess when we type in exit, because exit is the command to exit the loop. So if we clear and we run the program again, it says make a guess, we guess H, and it says H was found in Hangman. Now of course we'd want to change this if we were playing the actual game so that we don't give away what the word is, but we see the principle. So it says H was found in Hangman. If we guess U, it says incorrect guess because U isn't in word. If we guess exit, it prints exit and it leaves the while loop. If we run that again, you see now we can just keep guessing over and over and over until we decide to either leave or until. Interesting. Okay, so here's something interesting that I just picked up on. So what will happen now is that even if we guess the word correctly, if we type in Hangman, it says we guessed the word correctly, but we're still stuck in the loop. So I guess that's why we actually have to put this outside. Nope, that's not what we have to do. Oh, okay. So what we actually need to do is add this line underneath here. So now we'll exit based on two conditions. We'll exit if the word was identical, if our guess was identical to the word, or we'll exit if the guess was equivalent to exit. So let me just terminate this program and then rerun it. Now we can make a couple of guesses, H, A, and then we can guess the entire word now. And it says you guessed the whole word right, and then incorrect guess. Now this is peculiar. I see. It's because I removed the Elif there. Okay, now we can make a guess. Can keep making guesses, and then when we guess the entire word correctly, it says you guessed the whole word right, and then it exits the loop. Now an alternative way to loop through something would be to use a for loop. Now, like I mentioned, a while loop will go on forever, but a for loop can be programmed to run a certain or a fixed amount of time. So a for loop simply initialized by writing the word for and then creating a temporary variable. So we can say for num in range. Now this is a new function as well, the range function. The range function creates an iterable object. I'll explain what that means in just a second. What we can do is say print number or print num. And if we clear and we run our program, okay, so range needs a number. Let's say 10. Let's save that. And now we get the number 0, 1, 2 all the way to 9. Now what range does is it creates an iterable. An iterable is basically an object that can be indexed. So when I say an object can be indexed, what I'm saying is that we can go into the object and print out a specific we can go into a variable and print out a specific part of it. So for instance, a string is iterable because we can do something like this. We can say word, and then we can print the first value in word. If we run the program, we get h, which is the first value in the word variable. Now you notice that I wrote 0 instead of 1. That is because in Python, in fact in programming or in most programming languages, we start counting from 0, which is why when I run this, when I run for a number in range, it also starts counting from 0 and it excludes the number 10. So when we use range, the lower bound is included but the upper bound is excluded. So in this case it would be 10. Now we can we can enter the explicit range that we'd like to count through. So we could say we'd like to start counting from 5 until 10, and then we save that and we run it, and you see our lower bound is 5, so 5 was included. However, our upper bound is 10, and therefore it was excluded. So by default, the lower bound is set to 0 unless you add more than one value within your bracket of range. Something else we can also do is add a third variable inside of our, or add a third parameter inside of our bracket here, and that would be the number of steps to take. So if we wanted to print out even numbers, we could just put in 2 there, print our numbers, and it would count evenly from 0 until 8, as because we used the number 2 there. And you can also use negative numbers, but if you use negative numbers, then you would have to change the order of your range. Now I don't think that there would really be a use case for this, but perhaps there is if it exists. So now that we change the numbers around, it starts counting from 10 until 2, and 0 is excluded. So for instance, if I set the lower bound or the upper bound in the reverse to 2, the number 2 would now be excluded. So it would be 10, 8, 6, 4. So if we flip it back around and we say 10, oh, we need to remove that. Now we get 0, 2, 4, 6, 8. So now essentially we can declare how many times we would like our loop to run. Instead of having a loop that runs forever, we can have a loop that runs for a certain amount of time, and in this way we can essentially give our player a fixed amount of lives. So let's say we want to give our player 5 chances to guess the word correctly. We can bring this back up. So if we bring this back to the top, you just have to change it just a little bit. We can say for number in range 0 to 5. Okay, we're gonna make a guess. We're gonna print out our guess. Or maybe we don't need to print this. We don't need this line anymore. So we're gonna make a guess. We're gonna first check if the guess is equivalent to the word. So in while loops, our breaking condition or our stopping condition is set by turning the condition to a false value. But when we use a for loop, we need to set a different type of breaking point. Now, in order to break out of a for loop, we can simply use the keyword break. If we use break, then the program will run, and if it gets to this condition here, it will reach the word break, and it will say, okay, that's I've done what I needed to do, and then it will leave the for loop. And so essentially we can do the same thing down here and say if guess is equivalent to exit, break. Okay, and we save that. So just to run through what is going to happen here. Oh, we need to add one more condition actually. Okay, so what's going to happen here is it's going to initiate the for loop. And it's going to say for number in the range of 0 to 5, guess, make a guess. If the guess is equivalent to the word, print this out and then break out. If the guess is in the word, then print the guess was found in the word. Otherwise, if the guess is equivalent to exit, then break out. Otherwise, print the guess is incorrect. Now this is gonna run 5 times unless these two conditions are met. However, what if our player exhausts all of their chances? So what we could do is add a last condition to check if our number is equivalent to 5. or rather 4. The reason why we choose 4 is because of the range. Remember that the upper bound is excluded, meaning that the last number will be 4 instead of 5 in this range. So we can evaluate if the number is at 4, and if the number is at 4 and it hasn't broken yet, that would mean that we guessed incorrectly and we couldn't guess the word right. So we could then print out the word was, and then word, you lose. We could save that, and now we run our program. So we make a guess. Our guess is R, incorrect guess. We guess O, incorrect guess again. We guess A, it says A was found in Hangman. We guess man, it says man was found in Hangman. And now if we guess incorrectly again, it says incorrect guess, the word was hangman, you lose. And alternatively, we can make guesses, keep guessing, and then we could just simply type exit, and then it would break out of the program, or out of the loop rather. Or we can make guesses, and then guess the whole word correct, and then it says you guessed right, and then it breaks out of the loop. Now it would be up to you which one of these loops you would like to use in the project. So what we can do now is we can just take this whole thing and then move on to our Hangman file, and then let's overwrite this. So up here we have our word, and then we have our gallows, and we say for number in range 0 to 5, make a guess. If you guess the whole word, let's print you guessed the whole word right. If the guess is in the word, we'll say guess was found in the word. Otherwise, if guess is exit, let's leave the program, or let's leave the loop. Otherwise, print incorrect guess. Now what we can also do is print gallows, and then if the number is equivalent to 4, print the word was word, you lose. So we could use this example, and let's run our program now. We're gonna run our Hangman program. Now it says make a guess. Let's guess P. It says incorrect guess, and we get a Hangman. We guess again, we guess U, incorrect guess again, we get Hangman. We guess, I guess H. It says H was found in Hangman. Now let's guess the entire word, Hangman. It says you guessed the whole word correctly, and we're out of the loop. So you could either use this version, or you could use the while loop version, and you'll basically get the same. Now in this version, your lives are based off of your range. Now if we were to use a while loop, we'd have to have a different condition. So what we could do is say, okay, we're going to change this to a while loop now, and say play on, and we're going to create play on variable, play on equals true. We could also easily say true instead of play on, and then if the guess is equivalent to the word, print you guess the whole word right, and then instead of having the stop condition, we could also use break, and then in this case we don't need this line here. So let's save that and run it again. So let's make a guess. Let's say exit. it breaks out instantly. So if we ran the program with the break instead of a stop condition, we can start guessing, and now we have infinite lives in this scenario. So we keep guessing, we keep guessing, we keep guessing. So if we wanted to add the lives, or the concept of having a limited amount of lives here, what we could do is we could create a variable to keep track of a count. We can say lives equals 5, and then each time that we don't guess the entire word correctly, we're going to subtract a live. So what we can do then is lives equals lives minus 1. We could do that. Okay, before we run our program, we can also add a new if statement. Now we can say if lives equals 0, then print the word was and what the word was, and then you lose, and then break. So let's save that. Now we have 5 lives. Actually, let's also print our lives as we go on. So let's print lives and lives. We could subtract a life if the guess was incorrect. However, if the guess is correct, they can keep the number of lives that they have. So 5 lives, we guess U. Now we have 4 lives. We guess O. We have 3 lives. We guess H. We still have 3 lives, and H was found in Hangman. So now we are a little bit safe. We guess A. Okay, A was found. And we can keep guessing until we guess correctly, or until we run out of lives. So if we let's just keep going until we run out of lives. Now we have 2 lives left. We guess again. We have 1 life left. We guess Y, and then we incorrect guess, we die. The word was Hangman, you lose. And that's basically how the Hangman logic would work. And we can play the game again, except this time we win. We can say H, and we can say Hangman. Now we won with 3 lives to spare. So that's the basic implementation of Hangman thus far. In the next video, what we're going to do is we are going to create a list of words so that we are able to we're able to have different options to pick from. And we're also going to change this image so that we gradually draw the hangman instead of always drawing the entire hangman. And yeah, that's basically it for this video. So once again, if you like this video and you'd like to support the channel, you can do that by subscribing to the channel and hitting the notification button. You can also like and share the video, which would really help with visibility. Alternatively, you can also drop a comment of your questions or whatever concepts maybe you'd like to see in the future of the channel. Otherwise, that's it for this video, and I'll see you guys in the next one.